All right, let's get started with 0.4, factoring polynomials. Let me get my pen, and off we go. All right, so we are factoring in this section. We're going to factor out the greatest common factor to start. And then we're going to work on a couple of formulas that you're going to see, like common situations where you're going to factor out. And then we're going to potentially learn something new. I would imagine not all of you saw this in Algebra 1, which is factoring by grouping. Okay. All right, the biggest thing on this is that factoring is the reverse of distributing. Okay, so factoring is dividing, distributing is multiplying. All right, so we want to divide everything up. That's kind of the key to this section. All right, so if you want to pause, here's our summary with all our formulas. The biggest one here, if you want to pause and just get these down, the special formulas, those are going to come in handy, right? And then we're going to explain this and this and this. So I wouldn't necessarily, that's a horrible arrow, wouldn't necessarily take the time to write those down, but I would take the time to write down these formulas here. Okay, the greatest common factor. Instead of talking about the definition, let's instead just go into some examples. Probably a better way to describe this. So 7x plus 21. What is in common between 7x and 21? A 7, because a 7 could divide away from 7, and 21 divided by 7 works out also. So you take the 7 out of both of them and put it in front, you're left with x plus 3. All right, so a couple more examples. And the other one that we're going to look at is, excuse me, what happens if we have variables? So can we divide out a variable from each of them? We're going to find the smallest degree. So 1 here would be the smallest degree. That can come out front along with a 3, because 3 divided by 3 and 12 divided by 3 works. And so we end up with 3x. What's left over? X plus 4. All right, so let's dive into a couple quick examples here. So 6 and 18, you can divide both of those by 6. X to the 5th, x to the 4th. X to the 4th is the smaller. So 6x to the 4th factors out. That's the greatest common factor. We're left over with x to the 1st minus x to the 4th divided by x to the 4th cancels out completely. 18 divided by 6 is 3. All right, what about this one? I see a 6, a 10, an 8, and a 12. Those are all four of those are even. So we can factor out a 2. And what's the smallest degree? X squared. And so we are left with 3x. 5 minus 2 is 3, minus 5x. 4 minus 2 is 2, minus 4x plus 6. All right, give it a shot. Hopefully you factored out a 4x, and you're left with 3x squared minus 1. So careful on that one. 4x divided by 4x is not 0. 4x divided by 4x, because that's what factoring is. Factoring is dividing. So 4x divided by 4x is 1, which is what you're left over with. And in the next case, a 3 goes into both of them, or all four of these terms, and an x squared does as well. And we're left with x cubed minus 3x squared plus 4x minus 2. All right, so we've got our special formulas here. So I think you might have already written these down from the summary, but if you haven't, get these down again. And we're going to dive into each of these. So x squared minus 9. So we have seen this before in the last chapter of multiplying together to get x squared plus minus 9. What happens if we break it apart? X squared is a perfect square, and so is 9. So we can say x minus 3 and x plus 3. Because 3 times 3 is 9, and x times x is x squared. And if we were to FOIL this, the inner and the outer terms would cancel out. All right, same thing here. This is a perfect square, so we could say 2x. And then 25 is a perfect square of 5. 2x minus 5 and 2x plus 5. And x to the 4th is a perfect square of x squared minus 4 and x squared plus 4. All right, 4 times 4 is 16. Give it a shot yourself. And hopefully we got x plus or minus 2. We got 3x plus or minus 4. And for the last one, we had x squared plus or minus 9. Notice how the order doesn't matter. It can be the plus and then the minus either way. All right, factoring trinomials that are perfect squares. So in this case, You see a 9. That's a perfect square. 3 squared. Look at the middle term. If this is double 3, 2 times 3, what we've got here is a perfect square. So this is going to be x plus 3 times x plus 3. 3 times 3 is 9. 3 plus 3 is 6. And we get to write that as x plus 3 squared. In this case, we have x minus, because the middle term's a minus, and in this case, 5 squared is 25, and 2 times 5 is 10, so x minus 5 squared. It's that perfect pattern. And in this case, a little bit trickier to see, so we've got 3x squared gets us 9x squared, and 2 squared gets us to 4, so does 2 times 3x times 2, remember it's always 2 times a times b, does that get us to 12? It absolutely does. So in this case, we've got 3x minus 2 squared. Okay. All right, your turn. Give these a shot. These are all perfect squares. Plus 4 squared. X minus 2 squared. 5x minus 2 squared. All right, factoring the sum of 2 cubed. So on this one, x cubed is perfect, and 27 is 3 cubed. So we have the formula for this. What this is going to be a plus b, and then a squared minus ab, the sign is always the opposite, plus b squared. So here we have x plus 3, and then we have x squared minus 3x plus 9. And your turn. Try these. These are a little trickier. This is x plus 2, because 2 cubed is 8. And then x squared minus, always the opposite sign. And then we say 2x plus 4. All right. Did I get that on the last one? Yes. Just a reminder, it's b squared on the last term here. So on this last one, it's going to be x. 4 cubed is 64, so x minus 4. X squared plus 4x plus 16. All right, so factoring a trinomial is a product of 2 binomials. So here's our trick on this one. We're going to write this as a, b, c. These are your coefficients. So in this case, your a is 1, your b is 5, positive 5, and your c is 6. Your job is to find 2 numbers that multiply AC. So a times c, in this case, 1 times 6 is 6, and add b. So in this case, we're going to add to 5. Can we come up with 2 numbers that multiply to 6 and add to 5? So 2 and 3, right? So in that case, we have x plus 2 and x plus 3 are our factors. Okay, so another one on here, we need to multiply to 9, right? 1 times 9. We need to add to 10. Okay, how can we multiply to 9 and add to 10? How about 9 times 1? So here we have x plus 9 and x plus 1. All right, your turn. Multiply to 20 and add to 9. That's a 4 and a 5. So we're going to have x plus 4 and x plus 5. All right, what about this? What multiplies to negative at 28 and adds negative 3? How about 4 and negative 7, right? 4 times 7 is 28. Negative, you get negative 28. 4 plus negative 7, or 4 minus 7 is negative 3. We have x plus 4. We have x minus 7. Your turn. Hopefully, we got x plus 6 and x minus 7. All right, so what happens if the leading coefficient, the a, is not 1? This rule still works. What's our AC? AC is negative 10, and your b is 9. Can we multiply to negative 10 and add to 9? How about 10, negative 1? Okay. Now there's a little twist on this, and the twist is you need to take both of these and divide by 5x. Okay. Now I just put the x here as a little reminder. You'll see why in a second. Where's the 5 come from? Whatever that a is. This reduces, so 10 over 5 becomes 2 over 1x, and this is still negative 1 over 5x, doesn't reduce. At this point, we have our parentheses. This is 1x, you could write that as a positive, plus 2, and we have 5x minus 1. Okay. Your turn. See if you can use that trick. All right, so AC is negative 6, and your B is 1. To get to that, we're going to have a 3 and a negative 2. Let's put 2t underneath that. And we'll end up with, this does not reduce, so we have 2t plus 3 as one of our parentheses. This does reduce. This is the same as saying negative 1 over 1t. So we would have t minus 1, and that's your answer. Okay. Let's try another example here. So our AC is negative 15 times 6 is negative 90, and our B is negative 1. So what multiplies to 90? You've got to break this down a little bit. Let's see what we've got. 90 could be 2 and 45. That doesn't help us. 90 could be 3 and 30. Still not helping us. How about 90 could be 4? Does 4 go into 90? It does not. 5 goes into 90. 18 times, still not helping us. 90 and 6, not helping us. But how about 90 and 8 times 9? Okay, some of you may have jumped right to that. Sorry, times 9. 9 times 10, thank you. I could feel you trying to email me immediately the mistake. All right, 9 times 10, that has a difference of 1. So on this one, we would need to have negative 10 and positive 9. And let's put 15 underneath it. Okay, does this reduce? Negative 10 and 15, I can put my x's here as a reminder that that's the x term. We could have negative 2 over 3x. And on this, they both divide by 3, so we would have 3 over 5x. So here's our two parentheses, 3x minus 2 and 5x plus 3. Okay, give it a shot. AC is negative 72, B is 1. Okay, about 8 and 9, and the 8 will be negative. And so on this one, let's put a 6x underneath, a 6x underneath. And we reduce negative 4 over 3x and 3 over 2x. And so we have 3x minus 4. We have 2x plus 3. All right. All right. Identifying prime irreducible polynomials. Sometimes you can't factor. It's just the way it works. AC is negative 8. B is positive 1. Is there any way to break down 8 and add to 1? So how about 8 and 1? No. How about 4 and 2? No. And those are the only things that multiply to 8. So this is prime. So that's what we get to write. We say this is prime, not factorable. We're done. Okay. All right. Last thing we're going to learn is factoring a polynomial by grouping. So we only know how to factor x squareds as trinomials, x squared, ax squared plus bx plus c, okay, other than pulling out a common term. But we're going to learn a new term, a new strategy, sorry, for 4 terms. And the way this works is we're going to see if the first 2 and the last 2 terms have anything in common. So x cubed and x squared, what's in common? An x squared is. And we're left with an x minus 1. Plus, what's in common with the next 2? A 2. What's left over? An x minus 1. And so here's our factorization. We take the things that are by themselves, x squared plus 2, by itself, put that in parentheses. And we write x minus 1, the things that are shared in the other parentheses. And we are done. Now this only works if the 2 parentheses here match. Okay? The matching has to turn into one of the parentheses. All right, see if you can, one more example. Let's see. What's in common here? 2x, and we're left with an x plus 1. Now, what's in common here? A negative 1, which when we factor it out, we're left with an x plus 1. And so now we have 2x minus 1, the things not in common, times x plus 1, the things in common. All right, now it's your turn. Try it on this example. X squared, x plus 1, minus 3, x plus 1, So we get x squared minus 3. Next. Okay. All right, so there's your strategy for all of these. These are the things that we know how to do. All right, we'll try some more of these in class. And any questions, make sure you're asking those during the warm-up or when we're going over the practice problems. Okay. And I will leave these just for you. We're not going to do them, but there's some more examples for you here if you want to try these. Okay, just some final example problems. Okay, so give these a shot. And I think on these, we'll put up the answers to these in class just to see how we did. Okay, all right.